This is lesson 4.8 out of the Introduction to Algebra book. In my class, 4.8 is on page 95. And lesson 4.8 is titled Patterns and Functions. And the warm-up is to graph the following linear functions. Remember, linear means the graph will be a straight line. If it isn't, then you need to go back and find your error. If you're not sure how to do this, you should refer back to lesson 4.7. All right, the first one is to graph the linear function y equals 2x. And the second one is to graph 11. Oops. It doesn't start with 11, that's for sure. Y equals 11 minus 3x. All right, so you'll need to graph, let's see, you know what, I'm going to change this just so you don't have to make quite as large of a graph. Let's start it, let's make it a 9 and make this a 2. And then that won't be quite as large of a graph. All right, so we need and try to keep it kind of even on each side, and the same here. So middle line, middle line, middle line, middle line. Label. All right. If you have graph paper, this makes it easier. But if you try and be careful and keep them evenly lined up, you can get a pretty close approximation of your line. It takes practice and just getting an eye for keeping even spacing. Oops, which I completely messed up there. Even spacing. Let's try that again. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, and 9. All right. I could put a 10 there if I needed to, and I don't think you need to on that one. All right. So now we're down to our I can statement. What will we be learning in this lesson? I can write function rules for patterns. I can write function rules for patterns. All right, dark green pencil is gonna end of warm-up period and beginning of notes. And this is just one-page notes. It'll be right here. I have one notes piece that I'm going to glue right into the usual upper left corner of my notes area. We're going to be writing on this little notes sheet, so make sure that your glue is very thin smears so it doesn't soak through the paper and you'll be able to write on it. Okay, so vocabulary. Highlight that. And then with my pink highlighter, I'm going to highlight recursive sequence. We're talking about recursive sequence, all right? Now, a recursive sequence is something you've dealt with before. You maybe just didn't know it was called a recursive sequence. The definition for it is it uses a first term and a repeating operation to create an ordered list of numbers. So they're giving you the example here of 4, 7, 10, 13, 16, 19. The first term is 4, and it is increasing by 3 each time. All right? So this is very similar. It has its connections to what we've been doing with input-output tables and start value and a rate of change. Same thing. So while when they're talking about a sequence, they're calling this a first term, it's the same thing as start value. And while over here they're calling this a repeated operation, we know it as the rate of change, or rock. All right? Now, very small, we're going to write a little note in here. I'm going to talk about how a recursive sequence is always going to be changing, increasing or decreasing, which means by addition or subtraction operations. I want to point that out because soon you'll be learning about geometric sequences where they will be increasing or decreasing by multiplication or division. And that's what makes the difference. And you'll need to know that. That'll come up on testing quite a bit. What's a recursive sequence? What's a geometric sequence? A recursive sequence involves the operations of addition and subtraction, and a geometric sequence involves the operation of multiplication and division. Today we're only talking about recursive sequences, and we really have been talking about them already. You just didn't know that's what they were called. All right, so real small, I'm going to write a recursive sequence in a recursive sequence, the repeated operation is always addition or subtraction. Alright, so I'm going to take my red pencil and just box, red. Recursive, addition, subtraction, okay? Alright, so now we know what a recursive sequence is. Let's see what we can do with it. So I'm going to write the same numbers. Well, I guess it's the same numbers that's here, but we're going to write them a little bigger over here and kind of talk about them. All right, so 4, 7, 10, 13, 16, 19, and on and on. That's what the 3 dots mean, and so on and so on, okay? All right, so with my light blue pencil, I'm going to, remember light blue pencil is what we always used for start value? Well, it's also can be called the first term. Okay, start value or first term. And this is increasing by 3 every time. And so that tells me then that my operation is plus 3. All right, so now here's a question. This is what you'll see on your worksheet. What are the next 3 terms. All right. Well, we know it's increasing by 3, and the last term we see is 19. So if we add 3 to 19, we get 22. If we add 3 to 22, we get 25. If we add 3 to 25, we get 28. And so those are the next 3 terms in this recursive sequence. All right? Okay, so now I'm going to draw a light green line under this, because now we're going to move on to a different kind of problem, okay? And that you will also see on your worksheet. All right, I'm going to draw a blank right here, and a 10, a 14, an 18, a blank, and a 26. All right, what are the missing terms? Okay, what are the missing terms here? Well, we've got to find out what the operation is, all right? So let's look between the numbers that we do have here. So from 10, 14 to 18, I can see it's increasing. From 10 to 14, it increases by 4. So I'm going to put in there a plus 4. From 14 to 18, it is increasing plus 4. So it's looking like my operation is plus 4. So I'm going to put plus 4 here as well. And then I know if I add 4 to 18, I get 22. So there's my missing term right there. Now, I need to come up with what is the first term. All right, so what I know is that whatever I add to this first term, whatever this first term is, when I add 4 to it, it had better equal 10. So the other way, what's the opposite of addition? Of course, subtraction. So if I subtract 4 from 10, I get 6. And I can double check by saying, is 6 plus 4 10? Yes, it is. So that's the first term. All right, and now with my light green pencil again, I'm going to draw under, because now we're going to start another piece that you're going to find on your worksheet. Okay, we can also work with patterns with these recursive sequences, and I'm going to show you an example of how we do that. All right, so I've got what I'm going to call stage 1 of this pattern, and at stage 1, the pattern has 2 squares. Now, what I want to know is, what is the perimeter of this? Now remember, perimeter is what's all the way around, and we're going to speak of this as units, okay? So, how do we count the perimeter on this? Well, each one of these sides is a unit, so it's 1, 2, 3, 4, 5, 6. So the perimeter of this at stage 1 of this pattern is 6 units. All right? Okay, so now it's going to increase. At stage 2, we will add a third box. So a third square. 1, 2, 3. All right? So at 3, now what is the perimeter of this pattern? All right? Well, I can see that there's 1, 2, 3, 4, 5, 6, 7, 8. A quicker way to do it is just figure out, okay, how many units are at the top, how many units are at the bottom, and then add 1 and 2 for the sides. So I see 3 plus 3 is 6, 7, 8. All right? So it's 8 units. All right? Now, if I continue this pattern to stage 3, I'm going to add another box or square, which means it now has 4 squares. And what is the perimeter of this pattern at stage 3? Well, I got 4 and 4, that's 8, plus 1 plus 2, that's 10. So perimeter equals 10 units. All right, and I'm going to go one more stage to stage 4, adding another square. So now I'm going to have 5. 1, 2, 3, 4, and 5. And I want to know what the perimeter of the pattern is at stage 4. So the perimeter, and I got 5 at the top, 5 at the bottom, so that's 10, plus 1, that's going to give me 12. So perimeter equals 12 units. All right? Okay, so we drew out a sequence of patterns here. Now, what we have to figure out, and I'm going to write the question right under here. All right, so what will the perimeter be at stage 7? Okay. Now, to answer this question, you could keep repeating these drawings. We're at stage 4, to stage 5, stage 6, stage 7, okay? But you should be able to see that we have a pattern here that's going to allow you to do it with much less work, all right? Here's what I mean, all right? If we think of this 6 as our start value, or our first term, right? Then we can look at these numbers and see, well, what is our operation? What is our rate of change? How is it changing? Well, from 6 to 8, I see plus 2. From 8 to 10, I see plus 2. From 10 to 12, I see plus 2. All right? So, if my first term is 6, and then it goes on with 8, 10, and 12, and I know that this is stage 1, stage 2, stage 3, stage 4. Well, I can continue till I get to stage 7, just increasing the numbers by 2. So now I have 14, 16, I'm running out of space, and 18, because that's stage 5, stage 6, and stage 7. And they wanted to know, what's the perimeter going to be at stage 7? Well, the perimeter is going to be 18 units at stage 7. Okay? All right, so those are the 3 kinds of problems you're going to see on your worksheet. Let me see if I can get all the notes in the frame here. There you go. And so let's take a look at a few practice problems and see if you're ready for the worksheet. All right, here we go. Okay, here's our practice problems for lesson 4.8. The first one here has state the value of the first term and the operation and the next 3 terms for the recursive sequence that you see here. Right? So first term, what's the operation, and what are the next 3 terms? Right? All right, and the next one is, this is a problem that is just like what we did with the squares in your notes, only the pattern is a bunch of circles instead. But set it up the same way, and you'll see that the steps are the same. It's just they've changed it from squares to circles. Okay? All right, so I will go back to here for a minute, and you may pause and work on this one. And I'll go here and pause and work on this one. And now let's work these out. Hopefully you did well. Check your work against mine. All right, so the first term, of course, is 5. I see that the numbers are increasing. If I add 4 to 5, I get 9, so it looks like a plus 4. And test it out a couple of times. Make sure you're correct. If I add 4 to 9, I get 13. So yep, that's plus 4, and so on and so on. So my operation is going to be plus 4. So first term is 5. operation is +4. 3 terms. He wants to know the next 3 terms. What are they going to be? Well, I just need to look at the last term and see that if I add 4 to 21, I get 25. If I add 4 to 25, I get 29. And if I add 4 to 29, I get 33. Okay, so that's all there is to that. Now, let's look at our patterns. All right, so how many circles are in stage 0? All right, so in stage 0, I have 2 circles, right? How many circles are in stage 1? In stage 1, I have 4 circles. How many circles are in stage 2? In stage 2, I have 6 circles. Hopefully you're seeing a pattern starting to emerge in our numbers here. All right, so draw the next 2 stages in the pattern. All right, so what are they doing each time? Looks like they're adding another pair of circles each time. So the next 2 stages, I'm going to have 1, 2, 3, 4, and 1, 2, 3, 4, 5. There's my next 2 stages. All right. What is the operation that describes the change in the number of circles? What is it? How is it changing each time? Okay, it is +2. Okay, and then predict the number of circles in stage 8. All right, so remember we're starting at stage 0, and so our first term, I'm going to move this up just a little bit. Our first term is 2. Okay, oh actually stage 0. So let's that can really mess up when they're expecting it to start at 1. All right, so that was 2. 4 is stage 1. 6 is stage 2. 8 is stage 3. 10 is stage 4. 12 is stage 5. 14 is stage 6. 16 is stage 7. And 18 is stage 8. And it wanted to know, predict the number of circles in stage 8. I predict the number of circles in stage 8 will be 18. All right? Okay? So that's how you do that. Just mark it out with the stage numbers underneath so you know you got to the correct term they're asking for. All right, so that's practice problems. Let's take a look at your worksheet. Worksheet for lesson 4.8. The first part has you filling in the missing values. So you need to write down what's the first term and what's the operation, and then fill in the missing values. These ones where you have decimals, you're going to have to do some scratching out to the side to figure out, okay, how much did it increase from 7.6 to 6.3? Well, you know that if you scratch out over here, what's 7.6 minus 6.3? And you'll see how much it increased by. And then you'll know then that you have to, decreased by. It's decreasing. So you got to find your operation by looking between the numbers that they are given you. And sometimes you have to work backwards, like here. This is the only one that doesn't show you the first term. Okay? So figure out your first term, figure out your operation, and fill in any missing blanks. And then the last half of the page is a pattern. The pattern here is just like what we did in our notes. The one big difference I want to point out is it starts at stage 0, not at stage 1. In our notes, we started at stage 1. Make sure you circle this in red if you need to. Otherwise, when you get to the bottom and it asks you to predict the perimeter at stage 6, you could be 1 off if you do your numbering starting at stage 1. It's starting at stage 0 like we did in the practice problem. All right? Okay, so that's your worksheet. That leaves us with your exit ticket. is your exit ticket for 4.8. You can use this as extra practice. I don't show you how to do this or give you the answers. Okay, so that's lesson 4.8 out of the Introduction to Algebra book. Remember, the only way to learn math is to do math, and mistakes are proof that you're learning.